Thanks, Joel, for your talk. That was really informative, and also thank you for being a great partner all these years and getting this effort going. I'm going to just go over two recent experiments that we've carried out or in the process of carrying out on Humboldt Bay with the goal of trying to continue to refine the effectiveness of methods that we've already been using, developing new methods, and continuing to try to measure impacts of what we're doing, because this is an iterative, adaptive process. So for the first experiment, we were looking at contrasting some of the existing brush cutter treatments that we've been using for effectiveness as well as for impacts on the marsh. And this is the brush cutter treatment. Probably most of you are familiar with it. It's where we use a brush cutter fitted with a metal blade, and we actually grind below the surface of the salt marsh to kill the upper shallow rhizomes. So it's fairly disruptive to the marsh, and a big question for us has always been, you know, how deep should we go with these treatments, and how much impact does that end up having on the marsh, and how is that traded off with having to do less work later with return treatments? So that's one of the big questions this research at Jacoby Creek unit looked at. We were also interested, having been given some information from our partners that they were successfully using manual removal with shovels in some fairly dense Spartina. We wanted to test that more quantitatively. And again, in the way of refining treatments, we wanted to compare the efficiency of the way we were applying our grinding methods, where you go out with the brush cutter and grind through the top vegetation and then grind into the surface all in one step, with breaking that up into different steps where you do a top mow and then rake it up and then grind the piles and also grind under the surface. And finally, looking at what the abiotic impacts of these fairly invasive procedures were. And I say benthic invertebrate impacts, but that's going to be covered in a later talk. So this is the location of our first experiment. It was in this very dense area of Spartina near the mouth of Jacoby Creek, and this is a fairly recent growth of salt marsh with very, very dense Spartina. I think Joel showed a picture of it. So we put these 15 by 15 meter treatment areas out there randomly, well, in the spirit of randomness, while trying to encompass the variation in the tidal exposure. And the treatments that you're seeing here are basically a control where we do nothing, and then this light grind, deep grind, and the three-step grind that I mentioned, as well as the dig. We did baseline monitoring, and then we're monitoring it throughout the project. We're collecting data both on abiotic and biotic variables. So the biotic samples are much easier to collect. That's just plant cover data and density. And so there are 20 of those in a treatment area and only 10 of the abiotic samples. So this is what the site looks like before any treatment happens. And these are the samplers doing the initial baseline sampling. The cover of the plant species is collected in a small quadrat that you see in the sampler's hand there. And then the density of Spartina is in a much smaller plot because it's very time consuming to count. So we use flags to demarcate the area on the ground, and you can grab that in those combs in your hand and then kind of count them out one at a time. The abiotic variables we collected were oxidation reduction potential. So this is a measure of the activity of oxidizing and reducing compounds in the soil, which control how much oxygen is available. And also elevations of the marsh, which we collected with a laser level. So again, the treatments, I'm going to go over them in a little more detail. This is what we called the light grind treatment. So this is what it looks like in a strip that's been done. The target is to grind to 2 to 3 inches. Of course, in reality, achieving exactly 2 to 3 inches is really sketchy. So there's going to be a lot of variation in how these are applied. And as the mower is grinding, first grinds the top vegetation and then into the soil, the mower side casts the material. So you end up with this fairly smooth looking area of debris, or what we call rack. And this is an area of deep grind. You're seeing a little more ponding water here. So this is going down 5 or 6 inches. And those depths were determined based on what we consider to be a pretty good gauge of the shallow treatment getting, some portion of the deeper rhizomes, but not all, and the deeper treatment getting almost all of the deep rhizomes. So again, we're looking at the trade-off in efficiency of getting them all in a one go, as opposed to spending less time the first time and having to come back more often to treat resprouts. And then balancing that with the amount of impact that's occurring when you go the extra depth. And then finally, this 3-step treatment that came about just based on some of the restorationists observing that this might be a more efficient way, because you can go through quickly and mow down all the top plants, which makes you a little bit better able to see what you're doing when you're targeting the individual plants. So you mow it down and then you sweep it up or rake it up into these piles, and then the workers actually grind these piles down. And the point there is that we want the rack to be in small enough pieces that it's dispersed readily out of the marsh and through the water column, and not stranding itself in large areas of rack that can then cover native plants or have other negative effects. Finally, the shovel dig was just, your basic back-breaking labor, and it took less than 1 full day to decide that this was completely not an efficient method for this situation, so we never even finished a full plot, and these workers were very happy for that. You can see what ended up happening when the Spartina this dig is they were essentially trenching it, and then they were creating this massive amount of material, both plants and soil, that was being stockpiled and was going to have to be dealt with. So this is just a quick picture of 4 of the control plots. Between August of 2010, we applied the treatments in late winter, early spring of 2011. And I just wanted to show you that, in fact, the control areas were maintaining, although in the very last picture here, they're looking nice and green and clipped, because we had to go in the before seed set in the summer and remove seed heads so that they didn't affect, they didn't spread out all over the rest of the site. Some quick pictures showing what the progression looks like. So that's before treatment. This is June. By the following summer, August, we're starting to get some higher tides, and then this is just a couple days ago. And you'll notice that there's been a very extensive algal bloom, and that was expected based on all of our earlier work, and that is going to be talked about a little bit by Simona later today. And this is a deep grind plot, very similar, but perhaps wetter, because the elevation perhaps was lower, or it could have been the site on the marsh, that particular one was. And then deep grind. So all of these are just really showing work between March and December, so it's still pretty early in the process. And as far as one of the goals of this, again, was to look at the efficiency, and it was a little bit surprising to me that the deep grind was not a lot more time consuming than the light grind, and I think that partly had to do with the fact that it was difficult for the workers to really know exactly whether they were doing deep or light. But overall, I mean, the saving of 70 hours per acre is something now that we can measure against the time that has to be returned to do resprouts in those light grind areas. And yes, we're not going to be doing any digging. We did expect to get seedlings coming up, and that 40 hours per acre is dealing with seedlings. So now on to some of the impacts. We did measure the elevation both right before and fairly soon after the treatments, and we did find loss of elevation. You can see there's a pretty high amount of variation there, so the only thing that really showed a significant loss of elevation was the light grind, which was totally counterintuitive to me. So I had to think about that and draw some pictures to make it work. So this This represents a block of marsh right here, and this is the depth at which a 3-inch grind goes and the depth at which a 6-inch grind goes. And if you think about what they're doing in there, they're grinding the soil up, they're aerating it, they're basically creating less compaction, and then it gets side cast. So as they go along, there's probably at least an initial increase in elevation, if not equal. And then with tides, you lose a certain amount off of the top. And so in the long run, after things have equilibrated a little bit, it would make sense to me that this is why we're showing less elevation loss in the deep grind and more in the shallow grind, because there was just so much more expansion of the soil in the deep grind. That's just a theory. However, if you look on to like the second sampling that was in September 2011, it's interesting to note that we did see recovery in the marsh, but also in the control plots. So it's a little bit kind of to be determined whether we were seeing, were we seeing a response in the control because of all the sediments we were liberating all around the marsh, or is this like a seasonal trend that would be happening? And the size of these elevation losses were in the vicinity of 1.5 to 3 inches, so it's not real large. So then as far as the effect on oxidation reduction potential, which I'll call redox, really we didn't measure this in the middle period, just in February, then again in September, and by that time, the only treatment that was showing a significantly lowering of that was the deep grind, which makes sense. So as expected, based on our past work, we did have seedlings coming up in our plots, but it was heartening to see that the deep grind treatment was an effective way to greatly reduce the number of seedlings that came up. And we assume this is because most of the seeds are in the top few centimeters, and in the deep grind treatment, we're probably either destroying, disturbing, resuspending, or whatever, but moving those seeds in the seed bank, making them unable to come up. So actually, there were very few resprouts in any of our treatments, and we were resprouts from rhizomes as opposed to seedlings. So we had anticipated far more resprouting in the shallow grind, and our group has talked about that, and we're feeling like the level of consistency and the standard of work that went on in these plots, because they were an experiment, was far higher than in a typical go out on a mucky day and have a lot of fun with a mower. So I still believe that there should be a difference in these different approaches, and part of the reason for that is just looking at the morphology of these plants. So here's a Spartina plant. The rhizomes tend to be shallow. This plant here has all of its rhizomes within the top 2 inches of soil, and even though this one looks like there's more down here, most of the rhizomes themselves are still up in the top 2 inches. On the other hand, here's a big beefy plant from the Jacoby Creek marsh, and this right here is a rhizome way down here at 6 inches. So I think that we need to understand better how the morphology of the plants perhaps responds to environmental gradients or other things that may guide us in targeting some areas to be more labor intensive and others not. So some preliminary conclusions: that both methods resulted in initial elevation loss. We had subsequent recovery of elevation, but overall there was a loss compared with the control, so we are lowering the elevation of the marshes. And at least in the deep grind plots, we are achieving a lowered redox potential, which may aid in mortality of plants, or the effectiveness of the treatment overall. The deep grind treatments did result in fewer resprouts, and further research needed on the variation in plant morphology and the rhizome depth. So that was the first experiment. The second experiment was something we'd been wanting to try for quite a long time, since we first really thought about trying to remove all of the Spartina in Humboldt Bay National Wildlife Refuge. We have one unit in particular, the Eureka Slough unit, that has about, it's a 70-acre unit, and it has, I don't know, something like 40-some acres of very dense Spartina. So, or maybe it's 70 acres. Annie can correct that. So from the beginning, we had an idea that, it was maybe time to step up from the manual brush cutters, and did some research on amphibious equipment. And it took us a while to be able to get our hands on an amphibious Marshmaster. So this is a pretty recent experiment. And the questions, so we went out and did it in a pilot project trying to answer the questions. First, what's the practicality of it? How can it maneuver? And since this particular Marshmaster we had available to us had only a mowing attachment, we were going to look at whether mowing alone could result in hypoxic conditions if the rack were retained on the site and result in mortality of Spartina. And then again, we were monitoring variables to determine the role of elevation and drainage. The reason that we had hopes for this treatment is because we, in an earlier, the year before, we managed to get this non-amphibious bobcat out on the marsh with a flail mower attachment, and it was able to make one pass before it got hung up and we had to call the tow trucks. But we were so impressed with the result of that one pass. This is what it looked like after, less than a year. And this was at the Jacoby Creek Marsh, which is a very low marsh. And so this led kind of to the hypothesis, this was along with some other qualitative observations, that if in a low marsh, and at this time of the year when the plants were going into dormancy or going into lower metabolism, that perhaps just a mowing or a crushing alone might result in mortality, which it did certainly in that area. So this is where we were working on this Eureka Slough, and we ended up using those two plots. They were about 2 acres each. And we were able to hire Lance Stolman from Concord, who brought both his airboat and his Marshmaster up, and we learned about that, how you get a Marshmaster around. You have to kind of push it when you're in really deep water. He brought an airboat. It can maneuver in shallow water and firm mud, but not really mucky mud, we learned. And it was able to maneuver perfectly on the marsh and get right up close to these tidal bank edges. They did end up doing 2 passes with the mower because it wasn't getting a lot of, it was missing plants. Getting the 2 passes resulted in a finer rack, which was not our goal. We wanted a coarse rack that would be likely to sit there on the site. So we watched the site, and about 2 weeks after we treated it, there was an 8.3 tide. Annie went out and took this picture, and you can see what's happening, that there's rack floating up on the high tide. It's kind of trapped within the Spartina that's still standing around it. So it looks like it's staying there, but a good deal of it actually did move off the site. It was seen in other nearby places. And this is kind of what we went out and found, a couple months later, was that the rack shown in yellow here was really pushed up against the back edge of the marsh. And so we did not get the cover of rack that was our goal. And then in addition to that, we also early on observed that these marshes had fairly different vegetation composition from Jacoby Creek that indicated they're actually a little bit higher elevation, and we haven't been able to confirm that just yet. We've only been able to take relative observations. So we ended up with kind of half the plot covered with rack, or a third, and 2/3 not. And we were able to observe a lot more green growth in those areas not covered by rack. So just in the last couple of weeks, some of the people that work for me, including Laurel Goldsmith and Desiree Davenport and others, were out collecting data on those 2 plots, measuring the depth of the rack and taking redox and elevation measures and counting the mortality. And this is very, very preliminary, but I thought it was promising. The p-value here is not great. It's 0.07, but there was a correlation between the thickness of the rack and the dead culms. And there was a significant correlation between both redox and elevation and dead calms. So our preliminary conclusions on this part of the project: Marshmaster can maneuver, it's efficient, it can do about 4 acres in a day using just one pass. Of course, whether you buy the Marshmaster and run it with staff from your agency as opposed to renting it or hiring a contractor, all of those things enter into the efficiency quotient. Our marsh was almost certainly higher than the Jacoby Creek unit, so although the rack backed up, much of it dispersed. And we did find relationships between redox elevation and Spartina mortality, and a weak one with rack. So those things indicate that there's some potential there for using it. However, at the elevation we were at, I think everyone's conclusion was that if we could have just snapped a finger and gotten the money to buy our own attachment, we probably would have tried a rototiller attachment, and at that elevation it would have been more effective. We do feel that the mowing technique was successful in terms of wanting to do seed suppression or as a first pass in a 3-step method, going faster than people could do it manually. And we definitely want to look into the idea of putting a crushing attachment on, because then the rack does really stay in place. So that's kind of where we are. Both of those projects are still in progress, and we'll be keeping you updated. But I do want to acknowledge the very, very, very many people that work on these projects, because they're doing a lot of hard work out there. So hope you'll see your name in the list. And for some of you students, you may have gotten some ideas from this, I hope, of potential senior projects, masters, whatever. We'll be happy to help you out there. Thank you. Did I use up my time?
I think while we're switching PowerPoints, we have time for just one question.
Yes. Trying to burn Spartina? We've only ever tried to burn it in piles. I think, it's really a wet environment to do burning. I don't think it would be feasible.